So scalar multiplication of a vector is also possible. Okay, say for example, if ஒரு vector a bar வந்து நான் வந்து represent பண்றேன், or 2 dimension கூட நான் represent பண்ணலாம், இல்ல நான் 3 dimension கூட I can represent. For example, 2i cap plus 3j cap. So here I am using 2 dimensions. I cap வந்து unit normal vector along x axis, and j வந்து is along y axis. Unit normal vector along y axis வந்து we represent using j cap. So if a bar வந்து if I am representing as 2i plus j, what would be the scalar multiplication of lambda into a bar? What is lambda into a bar? Assume lambda value is equal to 5. So what would be your answer for lambda into a bar?
10i cap plus 15j cap.
Yes, 10i plus 15j. So that is your scalar multiplication. Okay, so it can be 2D or it can be 3D. 3D na உங்களுக்கு addition da இன்னொரு k cap term வரும், அவ்வளவுதான். That's the basic thing. Okay, so that is your scalar multiplication. Okay, this is one thing you need to keep in mind. Going to the next part. அடுத்தது பாத்தீங்கன்னா it is a triangular law of vector addition அப்படின்னு சொல்லுவோம். So triangle law of vector addition. So we look at that also. So what is this triangle law of vector addition? Okay, so ரெண்டு vector நம்ம யூஸ் பண்ணி if I am representing two vectors both in magnitude and direction as two sides of a triangle, if I am taking them in proper order, அப்போ அந்த ரெண்டு vectors ஓட resultant is represented by the magnitude of the third side, okay, in the opposite order. So for example, I'll take two vectors, say vector p, say this is vector p bar, and I'm also representing vector q bar. Say this is vector q bar. So both I am taking, you can see how it has been represented. Okay, so now the resultant of these two vectors, I can complete the triangle. Let me use blue color. So I can represent like this. So either one, I can just add vector p and vector q and finish the triangle. So the resultant r bar is nothing but the sum of p bar plus q bar. So just I am adding it and I am representing. So this is basically your triangle law of vector addition. So you can name the triangle also as A, B and C. Okay, very simple. So when I am taking two vectors that represent the sides of a triangle, then the resultant of both the vectors can be represented as the sum of the first two vectors which make up the sides of the triangle. This is your triangle law of vector addition. Okay, this is necessary. And then we have அடுத்தது பாத்தீங்கன்னா parallelogram law of vector addition. So let's look at that also. So we'll see how the parallelogram law of vector addition is being put to use. இங்க வந்து it will be sides of the parallelogram, அவ்வளவுதான். அங்க வந்து it was the sides of a triangle. Here it is sides of the parallelogram, but there is a catch. Sides of the parallelogram எப்படி, whether it is going to be a common point of origin or not. இங்க பாத்தீங்கன்னா it was not p barum q barum, it's not having a common point of origin. அப்படி இருக்குல்ல, it's head to tail and again head to tail, அப்படிதான் இருக்கு. But here it's not like that. It's having a common point of origin. So let me represent and show you. So let me take the vectors p bar and q bar such that they make up the sides of a parallelogram in the மாதிரி. Okay, So say this is p bar and this is q bar. ஓகேங்களா? So p bar and q bar are making the sides, the adjacent sides of a parallelogram. Now the angle between these two, that is vector p and vector q, let's take it as theta. Okay, so that is the angle between both the vectors. Now we need to complete the parallelogram. You know that parallelogram opposite sides are, they are parallel, isn't it? The way you look at them, they are obviously going to be parallel. Okay, and they're equal also. So let me extend it. So now dotted line convention use பண்றேன். So now I have extended both the sides. Let me also name this parallelogram as A, B, C, and D. So I'm naming them. Now what I'm doing is I'm the resultant of both vector P and vector Q is represented using the diagonal of the parallelogram. So if I'm going to join the line to point C, now this will give me the diagonal. So this is your resultant R bar. Okay. So again, vector R can be expressed as vector P plus vector Q. So again, you can express it like this. Okay, but there is an angle theta. Now what is the angle made by resultant vector with P? So that is not theta. We represent that using beta. So it's not going to be theta. It's different here. Okay, because the angle is changing. It's not the same. சரிங்களா? So இங்கே we use a different formula. This is the diagram. So for this, you can find out what is the resultant also. So resultant is given in terms of P and Q, and the angle theta can be expressed as square root of P square plus Q squared plus 2PQ cos theta, where theta is the angle between vector P and vector Q. So this is the formula used to find out the resultant. இப்போ நம்ம டைரக்ஷனை கூட கண்டுபிடிக்கலாம். We can also find out the direction using beta. So there is a trigonometric relation for that. So tan beta is equal to Q sin theta divided by P plus Q cos theta. So this is the formula to find out what is the direction. So if you want to find out that angle direction, so we can simply say beta is tan inverse of this entire value, Q sin theta upon P plus Q cos theta. அவ்வளோதான். ஸோ நான் என்ன பண்ணியிருக்கேன்னா பீட்டா I'm expressing. That's it. So these are two prominent formulas that are quite important for you guys especially when we have calculations relating to parallelogram law of vector. So this is all about that. Okay, I hope this part is clear. So now we are moving on.
Sir.
Yes, சொல்லுங்க.
Sir, beta na அது theta by 2 இல்லையா sir?
Beta theta by 2 not necessarily. So it's not exactly half.
Sir, parallelogram na அது half வராதா sir diagonal?
Parallelogram half வரதா அப்படினா it's not necessarily going to be half all the time. So we are not establishing the relation between beta and theta here. For the condition கொடுத்தாங்கன்னா நம்ம obviously we can apply it like that. There is no doubt. But that is not the condition. We assume that beta is not going to be theta by 2. Not necessarily.
Okay sir.
Okay, well, yeah. Okay. So this is all we have to have in mind. So about parallelogram law of vectors. அதுக்கப்புறம் நமக்கு ப்ராப்பர்ட்டிஸ் எல்லாம் இருக்கு. வெக்டர்ஸோட ப்ராப்பர்ட்டிஸ் is definitely necessary for us. Okay, so that is 8, 9, fine. Okay, so vectors is you can add the vectors. Okay, so vector addition is quite possible. So next properties பார்த்துடலாம். So for example, First property, one by one we'll see. You can add vectors, say vector A plus vector B is same as vector B plus vector A. So ரெண்டுமே ஒன்று தான். ஸோ இது வந்து காமிடேட்டிவ் ப்ராப்பர்ட்டி இல்லைன்னா காமிடேட்டிவ் ரூல் அப்படின்னு சொல்லுவோம். ஸோ தே ஆர் வெக்டர்ஸ் ஆர் காமிடேட்டிவ் இன் நேச்சர். ஸோ தே ஹோல்ட் குட். அதே மாதிரி வெக்டர்ஸ் ஆர் ஆல்சோ அசோசியேட்டிவ். அசோசியேட்டிவ் ப்ராப்பர்ட்டி பார்த்தீங்கன்னா say vector p plus vector q the whole plus vector r is same as vector p plus vector q plus r within brackets. So இது வந்து associative property ன்னு சொல்லுவோம். So vectors are associative in nature. That's also one property of vectors. So these are the prominent properties of vector addition. So addition can be happening in like this two different ways. Commutative addition is also holds good, as well as associative addition also holds good. Okay. Again, subtraction of vectors also neenga pannalam. A bar minus b bar possible. Okay. So that is a plus of minus b bar appdin kuda you can write it. That's also quite possible. This is all about the properties of vectors, the basic properties that we are seeing. The next nama paaka poradhu is the component of a vector. So vector oda component eppadi eludradhu, that's very necessary and that's also crucial. So how to represent vectors as components. Well, let's look at that. Components of a vector. So for that we need to have an xy plane. So let me draw the axis. So this is x-axis, this is y-axis, and உங்களுக்கு எல்லாருக்குமே தெரிஞ்சிருக்கும் the unit normal vector along x-axis we call it as I cap. The unit normal vector along y-axis we call it j cap. Okay. So I am representing a vector now here. So say vector p bar. Okay, say this is vector p, like this. So vector p is making an angle of theta with x-axis. So x-axis order, it is aligned with angle theta. Then what would be the component of p along x-axis? Adavadhu px. What is the component along x-axis? How do we write it? Very simple. From vector p I am going to drop a perpendicular such that it forms a right angle triangle. இது வந்து O A B ன்னு வெச்சுக்கலாம். So OAB is right angled at B. So using trigonometry you can find out what is the component OB. So PX அப்படினா OB தான். So how to find out that value of OB? So what will be the corresponding value? Yes. So apply trigonometry, opposite and adjacent side. So which corresponding ratio? So let me go down. Yeah. Which trigonometric ratio is going to relate vector p? Vector p also you should relate plus OB. That is your hypotenuse and your adjacent side. So which one can we use? Is it cos relation or is it going to be sine relation? Adjacent side and hypotenuse. It's going to be cos theta, right? So what is cos theta? OB upon OA, isn't it? So OA தான் உங்களோட vector P. So that's nothing but OB upon vector P. So rearrange for vector P, this implies vector P is equal to, or you can say OB because we wanted, the component, isn't it? So go for a rearrangement. So let me just erase it here and write it. So OB is nothing but the component PX. அதுதான் நம்ம அங்க first எழுதியிருக்கோம். So PX upon P bar is cos theta. So what is PX? So PX is nothing but P cos theta. So this is your component. This is the x component of vector p. Same way, similarly, what is y component py? திரும்பியும் நம்ம எல்லாம் derive பண்ண தேவையில்லை. So you can find out directly. So if this is theta, what is this angle? மேல இருக்கக்கூடிய angle. It's 90 minus theta, isn't it? Yeah, totally it is 90 degrees. The full 19 gradunala, it will be 90 minus theta. Just substitute. That's going to be p bar times cos of 90 minus theta. So how much is cos of 90 minus theta if you substitute? That becomes trigonometric ratios. When you're going to apply the angle relation, you get p sin theta. All of that. So that is the y component. So therefore you get the vertical component as p sin theta. Done. So two components mein nama kandupidichachu. Let us write it here. So the x component is p cos theta and y component is p sin theta. So both components we have found out. So like this you can find out the components of a given vector along both x direction and y direction. Okay, so this is how we do it. Okay. So right angle triangle form ஆறதுனால நம்ம tan relation கூட you can use. So that is opposite and your adjacent side. Okay, so what would be vector p itself or just p can be expressed as under root of px square plus py square. So this is also one more prominent relation. Substitute panninga you will get p square sin square theta plus p square cos square theta. P when the common out editing abdina sin square plus cos square theta is going to be equal to 1. When you go to substitute it, so you will get the answer as p is under root px square plus py square. So sum of the squares of the other two sides. Simple. The Pythagorean theorem also is going to be relatable to this. Okay, very simple. 3-dimensional இருந்துச்சுன்னா இது வந்து for 2D. Same thing for 3D. How do you write? You will write under root of px squared plus py squared. Additionally, you will get pz squared also. That's it. This is going to be for 3D. 3-dimensional vector notation, you would use this corresponding formula. Simple. Okay, I hope this part is also clear now. So this is how you do go for components of a vector. Okay, that's rectangular components of a vector. Very important. Okay, so now we are moving on the next part. அது அடுத்தது வந்து நம்ம dot product பார்த்துடலாம். What do you mean by a dot product? So we'll see what is a vector dot product. Quite easy. So vector dot product பார்த்தீங்கன்னா it's related by two vectors if they have a common point of origin. Say I am having vector A and vector B. I wish to find out what is the vector dot product provided that angle between them is theta. It is a product of magnitudes of both the vectors A and B. So dot product வந்து நம்ம இப்படி எழுதுவோம் vector A dot vector B is equal to the modulus. நான் ஏற்கனவே சொல்லி கொடுத்திருந்தேன் how to express a modulus. So modulus of vector A times modulus of vector B into cos theta. So this is the formula that we typically use to find out the vector dot product. So which is nothing but AB cos theta. Once you evaluate the modulus. So this is how you represent a vector dot product. Okay, so this is something that needs to be known. So we are seeing all the formulas at once, and then we'll start with the questions. So next we have the properties of the vector dot product. So we'll see what are the properties of vector dot product. So we have different properties. First property we will see for parallel vectors. So ரெண்டு vectors parallel இருந்துச்சு அப்படின்னா உங்களுக்கு obviously அதுக்கு நடுவுல angle இருக்காது. So angle is going to be 0. Okay, so for parallel vectors, you know that theta is going to be 0 degrees. So what will be the answer? Cos theta is going to be cos 0, which is 1. So dot product, what would be the answer? A bar dot B bar is simply A into B, because cos theta is going to be 1. Okay, this is for parallel. Second one for non-parallel or anti-parallel vectors. Okay, and they are away from each other. So அப்போ உங்களுக்கு theta வந்து would be 180 degrees. So cos 180 value to be used. So I hope you guys know cos 180 would be -1. So what would be the answer? So A bar dot B bar would be equal to minus A into B. The magnitudes. Okay, that is for anti-parallel vectors. Next, third, if vectors are orthogonal. Okay, what do you mean by orthogonal vectors?
90 degrees, sir.
Yes, orthogonal vectors na perpendicular vectors nu kuda idu sollalam. When theta is 90, correctly said. So when theta is going to be 90 degrees, you know that cos 90 is going to be 0. So the answer itself, the dot product itself is going to be 0. So answer is 0 da. So that is for orthogonal vectors. Next, fourth, இப்போ பார்த்தீங்கன்னா it is unit normal vectors வந்து dot product of I cap dot I cap. Two like unit normal vectors வந்து all of them are equal to 1. That is I cap dot I cap, J dot J, அப்புறம் K dot K எல்லாமே would be equal to 1. So all of them like unit normal vectors, always it is 1. And last but not the least, unlike unit normal vectors, that is I dot J, J dot K, and K dot I, it's all going to be equal to 0. ஏன் it is 0 உங்களுக்கே தெரியும். ஏன்னா ரெண்டு யூனிட் நார்மல் வெக்டர் நடுவில் இருக்கக்கூடிய ஆங்கிள் வந்து 90, அதனால இது 0. அண்ட் ரெண்டு லைக் யூனிட் நார்மல் வெக்டர் பார்த்தீங்கன்னா அது ஆப்வியஸாக பேரலாக தான் இருந்தாகணும். ஸோ தீட்டா வந்து 0, அதனால இட் இஸ் 1. சரிங்களா, அதுதான் லாஜிக். அதனால தான் அது 1 வருது, இது 0 வருது. ஓகே, ஸோ தீஸ் ஆர் ஆல் தி டிஃப்ரெண்ட் ப்ராப்பர்ட்டிஸ் ஆஃப் டாட் ப்ராடக்ட். டாட் ப்ராடக்டோட வெவ்வேறு ப்ராப்பர்ட்டிஸ் தான் நம்ம இப்போ பார்த்துருக்கோம். So there are around 5 properties which we have briefly summarized. Okay, so this is how you express them. இதே வந்து நம்ம Cartesian coordinate system la kuda you can express. For example, say for instance, say if I'm going to give you two vectors, say in 3D plane or 3-dimensional, say P bar is equal to Px I cap plus Py j cap plus Pz k cap. அதே மாதிரி இன்னொரு வெக்டர் Q வந்து I am specifying as Qxi plus Qyj and Qzk. Okay, so we have two vectors which are 3-dimensional. As you can see, there are 3 unit normal vectors associated with them. So in this case, the angle between P and Q, that's vector P and vector Q, how do we express? Okay, we can express using cos theta. We are still in dot product, right? So cos theta is equal to vector, okay, because I've taken P and Q, let me change it. So it's vector P dot vector Q upon modulus of vector P times modulus of vector Q. So this is an important relation that you need to keep in mind when it comes to three-dimensional vectors, especially when they are having an angle of theta associated between them, we would use this relation. So இதை வந்து நீங்க expand பண்ணீங்க அப்படின்னா you will again get cos theta is equal to P dot Q what the values when I'm going to put, obviously you will get AX, sorry, I've used P, right? So let me put P. So I'll get PX times QX plus PY times QY plus PZ times QZ. மீதி எல்லாமே அந்த 0 ஆயிரும். அடுத்த the other combinations would become 0. So only these would remain. ஏன்னா it is the angle is 1. Okay, because cos 0 is 1. அதனால. Okay. So you will get this, and denominator you have modulus, obviously நான் சொல்லியிருந்தேன். So under root of px squared plus py squared plus pz squared times square root of அடுத்த for q squares in all three dimensions to be considered, qx squared plus qy squared plus qz squared. Done. So this is how we express the angle. Okay. So when you go to expand it, the expanded notation is this. When you go for calculating, especially when you have values, when you want to calculate, you calculate using these relations directly. So this is all about it. So இது வரைக்கும் நம்ம பார்த்தது எல்லாமே vector dot product. Next we have something called as vector cross product. So again, cross product, is quite vast. We have so many things. Okay, we have different laws associated to it, and the angle also is going to be sine. Okay, and we would be using a matrix method, which is a very easier technique to solve cross product of vectors. So matrix determinant method it comes in maths. It's an application of mathematics. So we would be seeing that also. That's quite vast. So if I start now, I cannot finish it within the given, we just left with some more time, 3 minutes hardly. That will take some time. So we'll wind up here. Okay. So this is all about the vectors. So you have any doubts here, you can ask. Okay. Yeah. I hope it is clear till here. So next, we'll continue in the next lecture. Okay, I hope uncle is also there. Yeah, any doubts, children, you can ask me. I hope it's clear till here, today's lecture.
Yes, sir.
Yes, okay, great.
Yes, sir.
Yes, children. So I'll send you the notes on the group.
Okay.
Go through them.
Manish.
Yeah.
Okay, thank you, Manish.
Okay, uncle, welcome.